Hello, Matthews Gatos here. Boy, do I have a treat for you. Instead of just doing derivatives, we are focusing in this video on higher derivatives. We're not just stopping at y prime. No, no, no. We're going to go to y double prime, which is the second derivative. We're going to go to y triple prime, which is the third derivative. Or if I want to go past third derivative, I'm going to look at the derivative in brackets n. So for example, fourth derivative would be a 4 in brackets. Now that's one way of denoting it is with these primes. So first derivative with the 1 prime, second derivative with the 2 primes, etc. Or I can add a squared to my derivative operator, which shows that second derivative, third derivative, or the nth derivative. So let's get started. In this first question here, I want to find the derivative of y equals x exponent 6, the second derivative. So let's start with the first derivative, bringing the 6 down, decreasing my exponent by 1. Perfect. Now let's do the second derivative, which is bring the 5 down. 5 times 6 is 30. Decrease your exponent by 1, and you get the second derivative is 30x exponent 4. Let's try another one here. So this one here we have f of x equals 2 minus x squared to the exponent of 10. So I notice here I'm going to have potential for chain rule because I don't just have x on the inside, I have x squared. So first derivative, power law, bring the 10 down. Derivative of the outside, keeping the inside the same, multiplied by the derivative of the inside, which is just going to be the derivative of negative x squared, which is negative 2x. And then all I have to do is multiply those together. And the first derivative is going to be 10 times negative 2x, or negative 20x, times 2 minus x squared to the 9. Okay, now I have a product, so I'm going to do the derivative using product law. So this is my first function, this is my second function. And to remember the product law, I use this 1d2 plus 2d1. So I have 1 and 2, I just have to do the derivatives on the side. So d2 just means derivative of the second. So the derivative of 2 minus x squared to the 9, bring the 9 down, decrease your exponent by 1, multiplied by the derivative of the inside. So the derivative of the inside is negative 2x. So tidying that up, d2 is equal to negative 18x, 2 minus x squared to the 8. Okay, and then let's do d1, which is the derivative of the first function, which is just negative 20. So let's put that all together. So the second derivative is going to be 1, negative 20x, d2, negative 18x, times 2 minus x squared to the 8, plus 2, which is 2 minus x squared to the 9, and then d1, the derivative of the first one, is negative 20. So I see this as a good question that I can do by factoring. So I definitely see a GCF. Let me make this a little bit bigger. So I'm going to factor out a GCF. So the second derivative is going to be, so I see a greatest common factor. They're both negative, so let's take out a negative 20. I also see that I have a 2 minus x squared, and the smaller exponent would be 8. So let's take that out. So negative 20 divided by negative 20, but I'm left with x, and then I'm left with negative 18x, and then this has the same exponent of 8, so that's gone. And then negative 20, oops, let's try that again. Negative 20 cancels, so I'm left with plus 2 minus x squared to the 9 take away 8 is 1. Okay, let's tidy that up on the inside brackets. So second derivative is equal to negative 20, 2 minus x squared to the 8. And then on the inside, I just have to tidy that up. So I have negative 18x times x plus 2 minus x squared. Okay, so we'll do this again. Negative 20 multiplied by 2 minus x squared to the exponent of 8 times negative 19x squared plus 2. And then just to be totally picky, I see that the leading coefficient here is negative, so I'm going to factor out a negative 1. So negative 1 times the negative 20 there would make it a positive 20. And then I would have 2 minus x squared to the 8. And I factored out the negative, so each of these would change to be their opposite sign. And then that would be my final answer. Okay, let's try this last question here. I want to find the first 5 derivatives. The fun does not stop at the first and second derivative. No, we're going to go all the way to the 5th. So the first derivative, bring the 4 down. It's going to be 4x cubed plus, bring the 2 down, multiplied by the, bring the 3 down, multiplied by the 2 is 6, decrease it by 1, minus the 2 comes down, times 5, and then the derivative of 3x is just 3. Okay, second derivative, bring the 3 down, multiply it by the 4, decrease your exponent by 1, plus bring the 2 down, 2 times 6 is 12, with just the x, minus 10. Third derivative, bring the 2 down times the 12 is 24x plus 12. And then we're going to go to fourth derivative, but remember we're not going to use 4 primes. We're going to use in brackets 4. So it's not y exponent 4, it's the derivative, the fourth derivative. So the derivative of 24x is just 24. And then the fifth derivative is going to be just the derivative of constant, which is 0. So that is your video on higher derivatives. I thought this example would illustrate it nicely. If f of x is coffee beans, then f prime of x is ground coffee beans, and f double prime is my happy place, coffee. So I hope this video helped, and I look forward to seeing you for the next one.